today we're going to talk about significant figures. We are going to be using significant figures this entire course. This is something that you need to learn early on so you can use it for the remainder of the semester. You can even be using this past this class in other science classes, possibly in college, and possibly in your careers later on in life. So the reason why we use significant figures is because the answers and the data that we give and we get from experiments can only be as accurate as the measuring tools we have. Or if we're just dealing with problems on a piece of paper and data is given to us, our answers can only be as good as the data that's given to us. You can't say something is more accurate than the information given to you. So in order for us to be able to use this in problems, we have to first understand what a significant digit is. So there's a few rules that we need to remember and understand what they mean. So the first one says that all non-zero numbers are a significant digit. So for example, 921. All of these numbers are non-zero numbers, so all of them are significant. So if I were to ask you how many sig figs or how many significant digits are present in this number, you would say 3, because all of these count. The next one is all sandwich zeros are also significant. So an example of this would be 901. We can notice how the 0 is sandwiched in between two non-zero numbers. So it counts as a sandwich 0. We know that non-zero numbers are significant, so the 9 and the 1 count, and we now know that sandwich zeros are significant, so each of these numbers count, so we, again, have 3 significant figures. The next one says, leading zeros are never significant. So an example of this would be 0.0901. Let's stick with similar numbers, okay? Leading zeros are those zeros that come before your first non-zero number. So here we have 2 leading zeros that never count as significant digits. All they are placeholders to tell us how small these numbers are. If we didn't have these zeros, we would just think it was 901. But with these zeros, we see that this number is actually a whole lot smaller. So these 2 zeros are not going to count, but we know that non-zero numbers do count and sandwich zeros do count. So again, we have 3 significant figures. Now, trailing zeros. Trailing zeros count if there is a decimal place anywhere in the number. So a trailing zero is going to be at the end of non-zero numbers. So for instance, let's say we had 3.0. Okay. Here is a trailing zero because it comes after a non-zero number, and we have a decimal place in the number. So here, our non-zero number and this 0 do count. So we have 2 sig figs. Now an example of this not counting is if we had 30. So our trailing 0, again, comes after the non-zero number, but there is no decimal place in this number, so this 0 does not count. Again, it is just a placeholder to tell us that this number is not 3, it is instead 30. So this is an example when we would only have 1 significant figure. So we need to know each of these rules so that we can look at a number and know how many sig figs are in it. So that when we do math problems, we can apply those rules. So in math problems, there's 2 rules that we also need to know. The first one applies to adding and subtracting, and the second one applies to multiplication and division. So adding and subtracting don't really follow these sig-fig rules. Instead, they say when you are adding or subtracting two or more numbers, your answer needs to be the least number of decimal places as the numbers in the problem. So for example, let's say we had 4.3 plus 5.07. What we want to do is say we have one decimal place in this number and we have two decimal places in this number. So that means that our answer can only have one decimal place. So what we would do is do 4.3 plus 5.07, and that comes out to 9.37. But we know that our answer can only have one decimal place. So our 3 is our one decimal place, so we look directly to its right, the first number to its right, and that's a 7. And based on rounding rules, the 7 is going to round the 3 up. So instead of it saying 9.37, it's going to change to 9.4 because we can only have one decimal place in our number, so we're going to round that 3 up. Now let's look at multiplication and division. This one says the least number of sig figs. So that's where our rules up here come into play. So let's say that we had 301 times 4.2. So what we want to do is say, okay, this first number has non-zero numbers and a sandwiched 0. So all 3 of these are significant. Here, I just have non-zero numbers, so I know both of those are significant. So here we have 3 sig figs, here we have 2 sig figs, and we have to go by the least number of sig figs from the numbers given to us in the problem. So our answer has to be the 2 significant figures. So what I'm going to do in my calculator, I'm going to do 301 times 4.2, and that comes out to 1264.2. All right. So what we have to do is say, well, I know that I can only have 2 significant figures. So I look at my very first numbers, the 1 and the 2. Those are going to be my significant figures. I look directly to the right of that last sig fig. It is a 6. A 6 rounds up. So we have 1, 3, because the 6 rounds it up, and everything else that's to the left of the decimal place is going to get changed to a 0. So our 1264.2 changes to 1300 when we only have 2 significant figures. Okay, so let's look at some of these examples. What we want to do is figure out how many sig figs there are in each number. So we have 4974. These are all non-zero numbers, so they always count. So we have 4 significant figures here. Number 2. We know that the 7 and 3 are going to count because they're non-zero numbers. So we have to go back to our rules to figure out if these zeros count. These are all leading zeros. They come before our first non-zero number, so none of these count. So here, we only have 2 significant figures. In number 3, we have 4.04. Our non-zero numbers count, and there is a 0 that is sandwiched in between it. Sandwiched zeros always count, so we have a total of 3 significant figures. Here, we have 4.0400. All right, so we know that our non-zero numbers count, and the 0 in between it, which is our sandwich 0, will always count. So we have definitely 3 significant figures here. Now here we have 2 trailing zeros. Trailing zeros count when there is a decimal place anywhere in the number. And here we do have a decimal place, so all of these numbers are going to count. So that's 1, 2, 3, 4, 5 significant figures. All right, now scientific notation. When we're looking at significant figures in scientific notation, you're just looking at the number that comes in front of the times 10 to whatever. So here we have 3.00. The 3, of course, counts, and these 2 trailing zeros will count because there's a decimal place in the number. So we have 3 significant figures. All right, we have 2 more problems. This is what you're going to be doing in the data that you're going to be getting from labs that we do this year. So an example here is, what is the area of a table if the length is 1.75 meters and the width is 3.9 meters? You all know that the equation for area is length times width when we're thinking about a square table or rectangular table. So the length is 1.75 meters and our width is 3.9 meters. So here we're doing multiplication. If we think back to the multiplication rules, it's a least number of sig figs. So here we have 3 sig figs. Here we have 2 sig figs. So our answer needs to be the 2 sig figs. So in my calculator, I'm going to put in 1.75 times 3.9, and that comes out to 6.825. I need 2 significant figures, so the 6 and the 8 are significant. I look directly to the right, which is a 2. A 2 does not round this number up. So what we're going to do is simply drop these. So it becomes a 6.8 meters squared. The very last problem we have here. What is the volume of a rock if the water in a graduated cylinder was 50.0 milliliters and rose to 60.45 milliliters? So this is called water displacement, and we can figure out the volume of any object based on the difference of volumes. So we're going to have 60.45 milliliters minus 50.0 milliliters. So what you want to do is this subtraction, 60.45 minus 50.0, and that comes out to 10.45 milliliters. Now the rule for subtraction was least number of decimal places. In this number we have 2 decimal places, and in this number we only have 1 decimal place, which means that our answer can only have 1 decimal place. So this 4 is our 1 decimal place, so we look to the 5. It's going to round that 4 up, so our final answer is going to be 10.5 milliliters.